the questions which come to organic chemistry, and I'm going to show you some of the tricks when you're setting papers, what you need to focus on more so that you can also get more marks. If I don't make it to finish everything, then I'll see if I can organize a class tomorrow morning. There are some people who are writing tomorrow, and there are some people who are not writing tomorrow, they are writing the other days. Anyway, still, if you have written already, still it will help you at the end of the year and the junior exams and the supplementary and the prelim. Anywhere you find, even university level, you will still use the techniques I'm going to give you. All right. On organic chemistry, you need to know what we call naming. There are some principles we follow when we are trying to do the naming of organic molecules. There are some principles we follow when we are trying to say the naming of organic molecules. Anyway, we have some homologous series we need to talk about. For the case of our examination guideline, we need to talk about, don't mind about my handwriting, we need to talk about the alkanes. Alkanes, yes, you need to talk about alkenes, this alkane, and then you need to talk about alkynes. So when we talk about these three groups, alkanes, alkenes, and alkynes, basically, what do you need to understand among this? How do you know that this is an alkane, this is an alkene, this is an alkyne? The first point is you have to know the general formula. What differentiates among them is the first thing is the general formula. You cannot go to the paper without knowing the general formula of these homologous series. You know that all the general formulas, whether it's alcohol, whether it's carboxylic acid, whether it's esters, whether it's everything in this organic chemistry based on our level, it starts with the CnH2n, and then now the story starts from there. You can now modify based on which kind of which functional group is it. So this functional group is going to make it to modify it. So because alkanes have single bond throughout, it means that they have an extra. They have 2 hydrogen bonds extra. So it means that in this case, we're going to have to add +2. That's why we added that +2. Then alkene, it has a double bond. So its general formula is CnH2n. All of them, they start with that. So if you are going to the objective and then you find such a question and the question is not specifying, the question is not showing this CnH2n, then you just know that where you are is what is not the correct answer. So it means that you just rule that out. Because now alkene, we said that alkene have 2 extra hydrogen bonds, hydrogen bonds or hydrogen atoms, then it means that alkenes, because they have a double bond, remember a bond, yes, one bond will take 2 hydrogens, for example. So it means that it has a double bond. So one part broke. So it means that there was a hydrogen, which made this one to be saturated. So it means that now, because we don't have those extra 2 hydrogen, therefore the general formula is going to stop there. In other words, listen carefully. These alkenes are the parent general formula for all organic molecules we study in this level. Why? Because all of them, they are derived from the general formula of alkenes. Then alkynes, because it has a triple bond, it means that it is losing more. It means that alkynes, they are short of 6 hydrogens compared to the alkenes. Alkene, they are short of 2 hydrogens compared to alkenes. Therefore, CnH2n H2, now because it is short, yes, is short of two hydrogen atoms for one bond, then another two hydrogen atoms for another bond. Therefore, there are four hydrogen atoms which are short if you are comparing it with the alkenes. So it means that that's why we subtract it with the 2. So basically, I have said that all organic molecules, they start with the general formula of this. If it has more, this one is we added 2 because of the 2 hydrogens which are added there. So 2. We added 2 hydrogens, the 2 hydrogens which I've added here because of the double bond on the 2 carbon atoms, then that is scooped out. Let me show you what I mean. If you have this, yes, so it means that this is a hydrogen. This is a hydrogen, this is a hydrogen, this is a hydrogen, this is a hydrogen. So 1, 2, 2 carbon atoms. So 1, 2, 3, 4, 5, 6. You understand? There are 6. Then now when you come to alkene, it's gonna be like that. So this is 1, 2, 3, 4. So it's short of 2. Then when we go to alkynes, it's gonna be like this. So this one is short of 4 compared to this. I think. So it means that each bond will take away 2 hydrogens. Because here, one single bond, I had here, if you look at it, I had 1, 2, 3, 4, 5, 6. And then when I come here, I put a bond here. It means that this and this, they were lost, and then this bond joined to form a double bond. That's why you have 1, 2, 3, 4 to form this. And then now, when this one and this are lost, then these parts, they join to form a triple bond. Then you remain with the 2 hydrogen, this hydrogen and this hydrogen. Hence, you form alkynes. I think I'm clear there. So basically, you cannot go to the paper without knowing the general formula. Yes. So that is the first point you need to know before you go to the paper. I will come back in other lessons, and then I explain everything in detail for alkanes, alkenes, alkynes. Then what you need to know is the functional group. What is the functional group of alkanes, alkenes, and alkynes? The functional group of alkanes is a single bond between the carbon atoms, single bond throughout. Basically, it has hydrogen and carbon, and remember that carbon is found in group 4, so it must have 4 bonds. If you make it less than 4, we will cross it. If you make it more than 4, we will cross it. So it must have, whenever you are counting the bonds, you must show that the bonds are 4. They must not exceed 4. For example, if you're writing methane, it's going to be CH4. So it means that there are 4. So when you are writing ethane, it's going to be CH3, so that if you draw, it's gonna be like that. So that 1, 2, 3, 4, 1, 2, 3, 4. So each carbon atom must share 4 bonds. I think I'm clear there. So that's why you're saying that the homologous series, the functional group of alkanes is carbon, hydrogen, and the carbon single bond throughout. Carbon, hydrogen, and the carbon single bond throughout. Then when you go to the alkanes, yes, what you need to look at is a double bond between the two carbon atoms, CH. And then now you can now top up with the hydrogen. Don't leave these bonds hanging like this. We'll ask you, what is this? it must be hydrogen. Some teachers, when they are writing, yes, they write them like that. It does not mean that that is correct. They are just writing like that because they are faster. They want to cover up a little bit of something, a big content. Yes. But when you are writing an exam, each bond must have its own atom. Don't leave it hanging, because if you leave it hanging, we will cross it and then you come out of the paper thinking that you killed the paper, yet the paper killed you. All right. So you put the hydrogens there. So that now when you count this, it becomes C. If you are condensing it, 1, 2, H2, C, H2. So that's how you can know that this is an alkane, this is an alkyne, this is sorry, this is an alkane, or this is an alkyne. Then when we go to the alkynes, they are also simple. Don't forget the principle that carbon is found in group 4. It must have 4 bonds. Remember, we don't have alkynes and alkenes for one carbon atom, because it must be between 2 carbon atoms. So it has a triple bond. It has a triple bond between carbon atoms. Yes, I'm just delaying a bit here, but I'm coming there because this is the parent of all others. So now I have, remember, 4 bonds, but I am already having 3 of them. 1, 2, 3. So the next one is going to be hydrogen. The next one is going to be hydrogen. When you condense it, it's going to be C, 1 hydrogen, C, 1 hydrogen. You see? So don't say that this is incomplete. Then it means that in between here, there are bonds which are there. So that when I count, there are 4 bonds on each carbon atom. 1, 2, 3, 4. 1, 2, 3, 4. So that's how we write. Now, let's go to the naming part of it. Because there is something where students mess. They miss and mess. All right. So when you are writing this, you have to know what we call the prefixes and then the suffixes. Because if you don't know these prefixes and the suffixes, then you end up not to be able to write the exact number of atoms. So remember that a prefix will show the type and the position of the substituent. And then a suffix will show the functional group or the homologous series that compound belongs. Now, look, you have alkane, alkene, alkyne. So, the suffix for this is going to be the last letters. So whenever I write, my name for this homologous series must end with A-N-E for alkane, E-N-E for alkene, Y-N-E for alkyne. That's how we identify them. It must end with that. If it doesn't end with that, then it means that I won't be able to see what exactly is it. Yes. So let's go to this. Now, after knowing the suffix, you need to know the prefix, whereby 1 means meth, 2 means eth, 3 means prop, 4 means but, not but, 5 means pent. Yes? Look carefully. This is different when you go to other homologous series like alcohols, when you go to the haloalkanes, and then when you go to the the ketones, when you go to the aldehydes, one will mean that, two will mean that, three will mean that, four will mean that, and five will mean pentan. So it means that when you are writing this, this belongs to alcohols, this belongs to alcohols, aldehydes, ketones. You see, only this goes to alkanes, alkenes, alkynes. What do I mean? Now, if I have one carbon atom, yes, single bond throughout, is going to be meth plus this. Let me show you what I mean. Let me show you what I mean in this regard. I'll come back to that so that you understand it better. So I have one carbon atom, one carbon, one, two carbon atoms. But now I have one carbon atom here with a double bond. Double bond, they are supposed to be four. All right. And then three carbon atoms. Yes. Yes, and then here, yes. Don't forget that this, all this means hydrogen. Please, in exam, it must be, if you leave them like this, we'll cross. Please, please. So now, this is what I mean. So if it's one, one means meth. But because it's single bond, it goes to that. And then it becomes meth, methane. Two means single bond, two means if, so it becomes ethane. What about double bond? It is two. Ethene. You see, it's a double bond because double bond we said is double. And then four is 1, 2, 3. It's three. Propene. You understand? Yes. Propene. After the third one, you need to show the position of the double bond. You need to show the position after the third one. The first one is fine, the second one is fine, the third one is fine, because even if I put this side, it remains the same. But after the third one, the fourth one, but, you need to show. For example, one, check. That one is 4. But I can have this, I can have this. Let me show you what I'm saying. I can have this single bond and then a double bond there. Yes. Now after that, let's put hydrogen. It's 1, 2, 3, 4. 1, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Yes. Cool. 1, 2, 1, 2, 3, 4. 1, 1, 2, 3. You add another one. 1, 2, 3, 4. 1, 2, 3, 4. That's how you write them. I think I'm clear there. That's how you write them. Now, the reason why we want the position after the third one is because now if I put this here, it will be different. So first of all, I have to identify the parent chain. 1, 2, 3, 4. 4, we said it means but. Yes, 4. But now I have the position 1, 2, 3, 4. 1, 2, 3. It is on carbon atom. The double bond is on carbon atom number 3. But when I go this side, it's 1. It's on carbon atom number 1. So I'm gonna say but 1 in. A letter and a figure, we separate with them with a dash. And then a figure and a letter, we separate them with a dash. But if I have a figure and a figure, then we separate them with a comma. We're gonna go all there and then we shall see them. I'm trying to be a little bit faster so that I can cover something bigger for those who are writing tomorrow. But you're gonna have real classes for this physical science, chemistry, because we have not been giving it time and dedication, but M.Saidi is here to give you this. And it will be interesting as we go on. All right. Now, so I said that after the third one, you have to show the position. Let me know if you have something to say or you have a question in the comment. I'll always answer that. Yes. All right. So, if we continue with that, we're gonna see that alkynes is the same thing. We don't have alkyne for 2. Sorry, for 1. We only have alkyne for 2. And after 3, you have to show the position. Think I'm clear there. Then let's go to the nomenclature of the naming of the other groups. Remember, we said that the other groups, we don't stop on but, we stop on that. Propan, ethan, methan, pentan. You see, we stop on that. Please don't confuse those two. For haloalkanes, aldehydes, ketones, alcohols, we don't stop on ethan. You have to add. All right. Concerning about isomers, you cannot go to the paper without knowing the isomers. I'm just trying to do a short brief for this. And then let's go to alcohols. Yes, alcohols. Alcohols, you need to know 3 things. The first thing you need to know is the general formula. Remember, I said that the general formula for these organic molecules come from alkenes, CH, H2, like that. Remember, this is an alkene. It's a general formula for an alkene. But now, because alcohols have the oxygen and the hydrogen, replacing one hydrogen from alkane, then it means that I have to add that OH on it. I have to add that OH from it. But one hydrogen was replaced. So it means that I have to add 1, yes, because they are supposed to be 2. But now only 1 was replaced with the OH. So it means that I have to add 1, then I add the OH. Let me show you what I mean. Alkanes are like this, CH3, CH3, for example, of a general formula, CH. Let me show you how these general formulas work. Some of you don't know. This 1 carbon, yes, how many carbons do I have? Number, there are 2. You see, 2. So it means that it's going to be 2. Understand? And then hydrogen. I want to know if this is an alkane. Hydrogen is 2 times the number, which is 2 plus 2. So this is CN2. Then this one is what? Is H. 2 times 2 is 4 plus 2 is 6. So I come here and I see Do I have 2 carbon atoms? Yes, I have 2 carbon atoms. Do I have 6 hydrogens? It's 3 plus this is 6. That's how it works. If you fail to get the formula, still you can use this method to find it out. Let me give you another example. CH3, CH2, CH2, CH3. Yes. Let me see. We use the general formula. Say C. How many C is there? 1, 2, 3. Yes, there are 3. You understand? Then now I go to here. I say hydrogen is 2. Yes. And N is, they said N is 3. So it is 3 plus 2. So I'm going to say CH is 3. This is H 6. Yes, plus 2, which is 8. So I come here and I count 1, 2, 3. Yes, it's 3. Do I have 8 hydrogen? 6 plus 3 plus 3 is 6 plus 2 is 8. That's how. It means that all the molecules of alkanes, they must obey this general formula. So all molecules of those organic molecules, they must obey the general formula of that homologous series. That's how it works. So now I say that in this case, alcohol, they have this general formula because they're derived from this alkane. One carbon is being, one hydrogen has been replaced. Let me show you what I was trying to say, because I went there just to show you how does this general formula work. Why do we say those general formulas? Yes, I know that sometimes the teachers may not show you all that, but I know that not only high school students, they watch this video, some are university students. So still, it can help you to know the reason why many students fail physical science, chemistry exactly, is because you don't know the core of the subject. And when you're in grade 11, they don't teach you the core of the subject. They don't teach you, however much chemistry is abstract, but you need to have the love and to know where did this one come from. That's why I'm here, M.Saidi. All right, let me show you how did the alcohol came from alkane and hence the general formula. I don't need to cram. No, I don't need to cram these things. You just need to understand. All right. Now, this comes like this. See, I'm just drawing this to make it magnified or structure formula H, 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 H. So now, if I have an alcohol, it's going to be the same thing. It's going to be the same thing. Yes, it's going to be the same thing. But in this case, it's going to change. I say that one hydrogen has been replaced with OH. So it means that I'm going to come, I remove this hydrogen, yes, and then now I replace it with OH. Now it is alcohol, it's not alkane anymore. And this will obey this general formula, not this one anymore. Why? Because I've removed one hydrogen. That's why here instead of 2, I have 1. And I've replaced another hydrogen with OH. That's why I have the OH there. Hence, the general formula for alcohol becomes like that. I think I'm clear there. Then, let's go to the naming of alcohols and the classes of alcohols. When you talk about the naming of alcohols, look at this. You have 3 classes of alcohols. The first one is the primary. The second one is the secondary. The third one is the tertiary. Yeah, some books, the primary, they indicate it like this, secondary like that, tertiary like that. That's what it means in some books, depending on which kind of book you are dealing with. Soon we'll be raising the distinction material in chemistry. Soon. Yeah, it's just still under the verification process. All right, so now I have one carbon atom, yes, two carbon atoms, three carbon atoms, four carbon atoms, and the OH. I have the second example, one carbon atom, two carbon atoms, yes, two carbon atoms, and then three carbon atoms, and then now I have that, 1, 2, 3, 4, 1, 2, 3, 4. Now let me just remove one carbon atom here, and then I remain with that. Yes, I think I'm clear there. So it's like that. So hydrogens there. And then I have another example, CH3. Like that. So it means that I'm going to have one carbon atom, two carbon atoms, a carbon atom there, 1, 2, 3, carbon atom there. All right. So 1, 2, 3, 4. So I remove one carbon atom like that, and then I put here. Yes. Look at this carbon atom. Look at that. Then where is my yes, this one is supposed to be here, not here. Carbon atom, and then I have OH there, so it means that I remove this. Yeah, so so that it looks neat. All right, look at this carbon atom, and then also look at this is OH. Look at this carbon atom. Sorry. Yeah, this carbon atom has two hydrogens. The carbon atom which has the functional group, the OH, has two hydrogens. In other words, is attached to another one alkyl group, one carbon atom. We call it alkyl group. While this one, it has one hydrogen, or is attached to two alkyl group, two groups of carbons. You see, this group and this group. While this one has no hydrogen, but is attached to three other carbon atoms. The reason it has only one, therefore it is a primary. It has two, therefore is a secondary. And it has three other carbon atoms attached. The carbon atom with the functional group is attached to three other carbon atoms. Therefore, it is tertiary. That's how you can get these alcohols without being disturbed. Which one is a primary, which one is a secondary, and which one is a tertiary. I'm gonna have these classes nicely as we go on, but we are just hitting on. They can ask you identify the homologous series. You identify the functional group. You identify is that a primary alcohol or a secondary alcohol. Then you have to show us that is a primary alcohol because the carbon atom with the functional group is attached to one alkyl group. Is a secondary alcohol because the carbon atom with the functional group is attached to two carbon atoms. Or the carbon atom with the functional group OH is attached to two other alkyl groups. The carbon atom with the functional group is attached to this carbon atom with the functional group is attached to three other carbon atoms. Am I clear? Or I hope you are you're trying to understand what I'm saying. Yes. Let's go to the third point, which we need to know about these alcohols. Naming. 1, 2, 3, 4. 1, 2, 3, 4. 5. 1, 2. 1, 2, 3. Okay. If I have this, remember it is an alkane. Once one hydrogen is replaced, it becomes an alcohol. Yes, I have this. Now I put the OH there. What about this? These are 2 carbon atoms. We don't need to show the position. Don't waste time. Is eth. Remember, these alcohols, they don't stop on eth. Eth. It doesn't stop there. You have to go up to there. Propan. You have to go, sorry, propan. Propan. Butan. It stops there. It doesn't stop on but. This but thing, eth thing, prop thing, they stop only on alkanes, alkenes, alkynes. From the rest, they go up to ethan, propan, butan, pentan, hexan, heptan, octan. Yes, they stop there. You don't stop. You don't go. You have to go to extend up to that point. Yes. So now what I'm saying is, now here you find the longest chain. 1, 2, 3, 4, 5. Don't forget to put the hydrogens. Each is 4. 1, 2, 3, 4, 5. So it's gonna be pentan. Pentan. It stops on pentan because it is alcohol. Alcohol. Let me write it clearly. Alcohol. These, remember I told you that the last letters, in most cases, they determine the functional group. So alcohols is this, OL. So it becomes OL. So it becomes pentanal. Pentanol. Pentanol. But I need to know the position of the functional group. 1, 2, 3. It is on carbon atom number 3. When I come from this side, 1, 2, 3. It is on carbon atom number 3. Therefore, it becomes 3 there. So it becomes pentan 3R. However, there are some books and some teachers who teach in the other way. Still is correct, but Mina, I prefer this way. How do they teach? You just say 3 pentanol. Yes, it's also correct. Yes. However, this is the most accepted. Yes, when you go to university, this can be challenged, but this might not be challenged. It can be challenged. Yeah, this one. That's why I'm saying that I like to teach KO. KO means that your answer cannot be discussed with the examiners. They just give you a tick. Then, now, what about if it is this? It's going to be 1, 2, 3, 4. So it's 4. So don't forget to stop up to there. Butan. Because it is an alcohol, it's going to remain with or. Therefore, 1, 2, 3. It is on carbon atom number 3. What about 1, 2, 3? 1, 2. It's on carbon atom number 2. Therefore, it's going to become butan 2 or. You see? So you take the lowest or the shortest. Yes, the smallest figure when you are counting them. So primary alcohol, secondary alcohol, and tertiary alcohol, if they're of the same kind, same number of carbon atoms and the same number of hydrogens, then it means that they are isomers. So if they ask you to write an isomer of one alcohol, you just change the primary into secondary. Simple. You change the secondary into tertiary. Simple. Yes. So this organic thing is just to understand. Just to understand. You don't need to cram. There is no memorization. Too much memorization that you're gonna memorize everything. No, man. You don't need to memorize too much. All right. Let me show you some of the questions. There are a lot of things I can talk about. Let me show you some of the questions. I got some papers here, and then let me just show you some organic part of it, just to see how we can name. Okay, this is alkane. Yes, this is an alcohol. Yes. The reason why I'm showing you this is because some people don't know the longest chain and a branched chain. This is not a branched chain. Look at this. If you are to count, you're gonna count by saying that this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. There is no branch there. There is no branch there. So it becomes 1, 2, 3, 4, 5, 6. So 6 is hexane. You go up to there. Don't forget it's an alcohol. Why do we say it's an alcohol? Because of this functional group. What is the position of this functional group? The position of the functional group, is on carbon atom number 1. Is on carbon atom number 1. Why do I say it's on carbon atom number 1? Is because of this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is 6. What about when I'm coming from this side? This is a straight chain. It's a straight chain. However much is... let me ask you a question. When you sleep on the bed, and you bend your legs, do you become a different person? No, you remain the same person. You understand? So it is the same chain. It's just bent. If there was a branch here, it would have removed this hydrogen and you put another thing. But this is the same thing. So therefore, I'll say is on carbon atom number 1. So it is, because it is alcohol, I'll put OL, and then is on carbon atom number 1 dash 1. Yeah, so it's going to become hexane dash 1 dash or. Simple. Yes, as simple as taking ice cream, because there are no bonds. All right. Let's go back to another homologous series. Yeah, there are a lot of questions I can discuss about, but we will discuss about them. This is just a small introduction, and just go through, to peruse through, to see where are you lacking. When you go to another homologous series, which is let's go to haloalkanes. Haloalkanes are also derived from alkanes, whereby the carbon atom, one carbon atom with, one hydrogen has been replaced with the halogen. We call it, you see, it's called haloalkane. They are alkanes, but with a halogen. halogen is a group 7 element. So it means that if it is an alkane, it means if the group 7 element, therefore it means that these alkanes, you need to know that these alkanes, they have 1, 2, 3. Yes, these are alkanes. So you take any, either fluorine, bromine, chlorine, iodine, not in the order, because it's fluorine, chlorine, bromine, iodine. That's the order. All right. Choose anyone. You say that easy. It becomes haloalkane. So when you are writing this, you start with the fluorine. Therefore, it's going to become fluoro. Bromine is going to become bromo. Chlorine is going to become chloro. Iodine is going to become iodo. Iodo, chloro, bromo, fluoro. So if I have iodine here, therefore it's going to become 1, 2, 3. So it's going to be, don't forget 2. You don't stop there. It's going to become, it's going to become the not bromo. 1, 2, 3. It's an alkane. Is prop is an alkane. 1, 2, 3. So it means that because it's an alkane, we add the word alkane. Alkane. We add this, and then it becomes propane. But it has this iodine on carbon atom number 1. Therefore, it becomes 1 dash iodopropane. 1 iodopropane. 1 iodopropane. So that's how we name it. Yes. Now, what is the functional group of it? The functional group still is going to be CH2, CnH2n plus. Remember, only one hydrogen has been replaced. So plus 1, and then we cannot put iodine here, bromine here, so we represent it with X. X. So it means that the functional group of alcohol and the functional group of haloalkanes, they are the same. Here, you only replace it with OH. For alcohol, for haloalkanes, you replace it with the X. I think I'm clear. Yes. Then we go to the next one. Just a bit of rushing because of the time, but still we will win. How do we? Sometimes these compounds are branched, yes, and if they are branched, what do we do? If they are branched, what are we supposed to do if these compounds are branched? So still you have to deal with them. I'll be giving you more examples and more examples and more examples. Before I end up, I will have to give you some few things concerning about the preparation. Things just rushing in a rush. The things which make students fail in terms of the properties, because I was not supposed to go there, but I'll just talk about those properties and how do we know which kind of bond is formed where and why. Then when you go to ketones and the aldehydes, the word ketone, you take the last. Aldehyde, you take the first. So the suffix for this is going to be, yes, so it means that it must end with this one and it must end with this or. The functional group for ketone and aldehydes are the same, but when it is at the end or at the beginning, at the terminal, it is an aldehyde. When it is in the middle, somewhere between the carbon atoms, then it is a ketone. Therefore, because aldehydes, the functional group is always at the end, we don't need to show the position. We don't need to show the position of the functional group. For example, 1, 2, 3, 4. CH, that is the functional group. So if I add a hydrogen here, therefore it means that it is an aldehyde. When I add another carbon and another carbon this side, it is a ketone. Yes. So now if I put it here, you don't forget to put four bonds. Yes. And then 1, 2, 3, 4, and then I put it there. Sorry. Let me just do it like this, so that is uniform. Yes, I put it there. So these are hydrogens, 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 hydrogens. 1, 2, 3, 4. Yes, 1, 2, 3, 4. 1, 2, 3, 4, 5. So the hydrogen is supposed to be removed. Yes. So now look. You have the hydrogen here, you have the hydrogen there, you have the, so now it's gonna be 1, 2, 3, 4. So 4 is, don't forget our naming. 4 is bute for alkane. For these other ones, you go up to there. So it becomes butane. 1, 2, 3. It's on carbon atom number 3. 1, 2. It is on carbon atom number 2. So I take the 2. So it's going to become butane dash 2 dash. Then I end up with this. On. Butane 2 on. Yes, as I told you that some people and some books, they can write them like 2 butanon is correct, but the most correct one, based on it, they will never discuss about it, is this. Right? Yeah, this one, if you are still on the lower level, correct, cool, good, but as you go on, yeah, some of you are gonna be chemists in masters. You have done chemistry in masters in chemistry. It means that I don't think they will allow you to use this. They won't. So you better start with something which you're not going to forget. If you're gonna be using it every single time you want to use it, and no one is gonna challenge it. Then this one is gonna be 1, 2, 3, 4. It's gonna be 4 butane, but now you end with this. Remember, it's always at the end, so that I don't need to show the position. So it's gonna become butanal. Butanal. Simple. Alkanes, aldehydes, and ketones, all of them, you don't need aldehydes, you don't need the position. General formula for the two, they are the same. Why is the general formula the same? It's because ketone is an isomer of aldehyde. So isomers, they always have the same general formula. And don't forget that they are derived from our general formula, CH, CN2HN. They're always starting with that. If they bring anything and then you don't start with that, just know that that is 0. Then the hydrogens have been replaced with an oxygen. So therefore, I put the O. So that is the general formula for aldehydes and for the ketones. Simple. Guys, I told you that you don't need to cram too much for these things to get them. You don't need to. You just have to understand the concept. That's all. You get the marks. All right. Lastly is the esters and the carboxylic acid. esters and the carboxylic acids. Esters and the carboxylic acid. For the case of esters, we don't talk about the what? We don't talk about the functional group. Yeah, aldehydes, yes, is 4-mile. It's a 4-mile group. Ketones, they are carbonyl groups between two. The group is bonded to 2 carbon atoms. Yes. Esters, we don't talk about the functional group. Alcohols is hydroxyl. When you talk about hydroxyl, you mean we mean alcohols. Hydroxyl. That's the functional group. Yes. Carboxylic acid is carboxyl. Carboxyl. Yes, it's a carboxyl group. So that's the functional group. Many members, students confuse the homologous theory and the functional group. Please don't confuse those two because those two are different. Anyway, let's go to carboxylic acids. I'm going to talk about esterification here so that you understand just why do we write these carboxylic acids like that and the esters, why do we write them like that? Duma, yes, I've seen you. Okay, I've seen the challenge your kids have. Okay, we'll try to deal with that. All right. Esters, they are derived from carboxylic acids and alcohols. So we have seen the alcohols, but we have not seen the carboxylic acid yet. So carboxylic acids, they end with the oic acid. Because the functional group is at the end, we don't need to show the position. Therefore, it's going to be like that, like that, like that. So because it is at the end, we don't need to show the position. It's always at the terminal, either end or the beginning, whatever. As long as it is terminal, yes. So we don't need to show the position. So if I have 1, 2, 3, 4, and then I have OH, you put the hydrogens, yes, it's gonna be no hydrogens here. It's gonna be 1, 2, 3, 4. So it's gonna be butane. Don't forget to end up there. Then I add this butanoic acid. Simple. If it is 5, is pentanoic acid. If it is 3, is going to be propanoic acid. Simple. So there is no stress there. Now, what about when you have this? Now this is it. What about now the ester? When I combine the two, this is how it forms. I have an alcohol, CH3, CH2, OH, plus a carboxylic acid, CH3, CH2, CH3, anti-alkane, yes, COOH, yes. The reaction, for this reaction to take place, yes, I will need sulfuric acid, not just sulfuric acid, concentrated sulfuric acid. Don't stop there. I will need to heat a bit. Yes, And then now, because then I'm gonna have something here which is an ester plus H2O, meaning that it looks like a condensation reaction because I've produced this. Anyway, let's continue. How do I form that ester? Draw or do the structure formula of each molecule. You'll be able to know exactly what happens inside there. Remember, I'm not showing you the synthesis, how these electrons move. What causes this to do that? That is university level. So there is a channel we opened. It's called Get Answered. Yes, there we will also be talking about university students, the chemistry of university. Yes. All right. So now CH yeah, it's fine, but I want to show you each and every bond. So these are hydrogens, guys. These are hydrogens. Then what about this? CH3, CH2, C. Yalla. So it looks like that. Yes. Now, how does the reaction occur? Why is this sulfuric acid there? It's acting as a catalyst. I don't show you all the mechanisms we use, because for here you just know how do they combine. That's all. A carboxylic acid will lose the OH and the oxygen, while the alcohol will only lose the hydrogen. Carboxylic acid will lose the OH, meaning that it will lose this, while the alcohol will lose this. When these two combine, they form that water. Now, remember this is now, it was a bond, but it got broken. And then this was a bond to oxygen, but now it's got broken. So this bond and this bond, half a bond and half a bond, they will join to form a full bond. Therefore, when I'm writing, I'm going to write again this C oxygen there with a half a bond. Now I'm going to bring this other half a bond, yes, and then I start to write from backward. You see, I write this, this is this, this is this, this is that. So what you have formed becomes an ester. So this is an ester. It means that the reaction is going to give me this plus H2O. Remember, H2O is a vent. Yes, is a V shape. Ne? Remember grade 11 with the electron pairs or free electron pairs of electrons. Okay, we are not in the shapes now. All right. So don't forget that all these are hydrogens. Ne? All these are hydrogens. So now, how do we name it? The part which came from the carboxylic acid becomes the parent chain, meaning that we're going to add the word OAT. OAT. And don't forget that whenever you say OAT, in science, it means negative. Yeah. Nitrate. Sulfate. Chlorate. I see. Yeah. Whenever you add the word this 8 thing, I don't mean you ate like you eat, the past tense of eat, ate. No, man. I'm talking about this is the past. No. I'm talking about the negative. Yes. Okay. So it means that this is a species which is negative in nature. All right. So now, so this is the one which you're going to add the OH. Why? you look at this carbon, the species which have carbon atom with oxygen double bond, it means that it came from a carboxylic acid. Therefore, it's going to be 1, 2, 3. So 3 is propan. Don't forget to go up to there. And then I add the word OAT, so it's going to become propanoate. Yes. So this one we regard it as an alkyl group, a side group. So it's going to be 1, 2, 1, 2, 2 is 2 is eth. But because it's a side group, we add the word YL. So it becomes ethyl propanoate. Ethyl propanoate. Basically, that is it. That is it. I need help with the vertical projectile motion. I'm writing on Friday. Please, Virakazi, oh, specific. Virakazi. Okay. Virakazi, we have had you. Let's see if we can organize a class on Thursday. Concerning about the vertical projectile. All right, guys, let me do the last part of the properties of these organic molecules. Basically, here we are talking about the boiling point, vapor pressure, and boiling point, vapor pressure, and the melting point. When you talk about boiling point, vapor pressure, and melting point, by the way, I've not talked about reactions. I've not talked about reactions because I had to talk about those reactions, the additional reactions, halogenation, hydration. You could talk about the substitution reactions. We have to talk about the combustion or oxidation reaction or elimination reactions, cracking. I didn't talk about all those reactions, and there are so many things we need also to deal with, and these kind of reactions. Mechanical fluid, how do we apply it? All those things. There is a lot of things we are supposed to talk about. Let me not rush too much because still I will get time and then make videos concerning about this. But specifically, when I talk about alkane, I make a full video on alkane, alkene, alkyne, haloalkanes, aldehydes, ketones, esters, alcohols, carboxylic acid. All of them, I'll talk about them individually. I go to the reactions and then I show you exactly how you cannot leave these so-called 50 towards 50 marks in exam without answering this. Actually, if you have organic chemistry alone, is enough to pass, to be more than 30%. So if you add others, then automatically, that's why I say that I don't see a reason why a student must fail this physical science. When you have such things which are simple, sometimes, yes, we make them complicated, but you just have to give them time, and then you'll see that, yes, things will work out for you. Things will, I repeat, things will work out for you. I need help with the vertical projectile. I'm writing, oh my God, he's writing tomorrow. Hi, can you please help me with the vertical projectile motion? I'm writing on Thursday. Oh my God. Mwalekwa, okay, and then Mosheni, eh? Mushweni. What? It's not Mutweni. Okay, Musheni. Okay. Let me see if we can make you a class on vertical projectile tomorrow. Let me speak to the teacher concerning about physics, because I only deal with the chemistry. So I will speak to the teacher who deal with the physics, and then so that we organize a class for you tomorrow, so that at least you are helped. Those who are writing to on Thursday, and then those who are writing tomorrow, I don't know now what I can do for you, but I would have helped you. I just see your concern, and thank you very much for bringing your concerns. Yes, we are going to try to help you so that you guys, you pass. Yes. All right. Let me show you some of the things which you need to know about the bonds. All organic molecules, listen carefully. You need to open your ears carefully. All organic molecules, they have what we call London forces. All of them, they have what you call London forces. So, when you're explaining London forces, just know that all organic molecules have London forces. Or if they ask you which kind of intermolecular force of attraction is found in this molecule, just know that London forces are found in all organic molecules. London forces are being caused by the mass the molecule has. So if the molecule has a bigger mass in terms of, in this case, we talk in terms of carbon atoms, the higher the number of carbon atoms, the higher the London forces. So London forces exist not in polar molecules. I think I'm clear there. They exist not in polar atoms. They exist in non-polar atoms. So the first force you need to know is the London force. London forces. That's number one. Number two, you need to know what called a dipole forces. Dipole force. Where does this here all organic molecules? Where does this one occur? Dipole forces only occur on atoms which are electronegative. So if the molecule has a high electronegative element, it's going to have a stronger dipole force. Don't forget that even dipole forces are also divided into categories, but we are not talking about the categories now. We are talking about dipole forces. Dipole forces are being designated, are being brought about by the electronegativity an atom is having. I'm going to give you examples. If you look at halogens, group 7 elements, you know that the strongest, the element with the high electronegative value is fluorine. Therefore, it means that it pulls the bonding pair of electrons toward itself. Look, the bonding pair is supposed to be like this. Okay? So now, if this is fluorine, it's gonna pull it toward itself, and then because it gains this. Remember, if you gain the electrons, you become negative, so it becomes partially negative, and then it leaves this one partially positive. So because it has created two poles, then it becomes dipoles. It has two poles, dipoles. So now, because there is also another pole, therefore it becomes dipole. Because those are forces between these molecules. Therefore, it becomes dipole forces. I think I'm clear. I'll explain this. I'll designate it to a specific lesson, but I'm just giving you highlights. So, listen carefully. What have dipole? Haloalkanes. Haloalkanes. Alcohols. Because alcohols. Why do we have alcohols? Because of the oxygen. Oxygen is also electronegative. It pulls the bonding pair of the electrons towards itself. Anything which has the halogen, anything which has oxygen, it has dipole forces. Esters, ketones, aldehydes, alcohols, carboxylic acids, haloalkanes, all of them, they have dipole forces. Now, I go to the third one. The third one is what you call the hydrogen bond. Hydrogen bond. Students who are doing life science, don't confuse hydrogen bonds with weak hydrogen bonds, and you think that hydrogen bonds are weak. Actually, in this chemistry, hydrogen bonds are the strongest. Any compound which has hydrogen bonds is the strongest. Therefore, it will require more heat to break these bonds. Hence, its boiling point will be higher. Therefore, when does it form hydrogen bonds? We only look at two molecules which have hydrogen bonds. That is alcohols and the carboxylic acids. Why not esters? To have a hydrogen bond, the oxygen must be attached to the hydrogen. Hence, it rules out aldehydes, ketones, and esters not to have hydrogen bonds. Listen, let me show you what I'm trying to say. If you look at ketones, they look like this. The oxygen is there. Therefore, it is electronegative. It pulls the bonding pair of electrons towards itself, but it doesn't. This oxygen is not linked to the hydrogen. Therefore, it has dipole, no hydrogen bond. But if you look at water, let me leave the water. Let me talk about alcohol. Yes, it has this. So this versus that. So this is pulls towards itself. So you see that here it is negative, and then this is partially positive. So it remains that you see that this is for hydrogen bond, and then this is for dipole. So because this and this creates the dipole, but because hydrogen bonds looks like dipole, but because it is between oxygen and hydrogen, is designated to hydrogen bond. So it is not between hydrogen and other molecules. It is specifically between hydrogen and oxygen. Therefore, they have two compounds. Sorry, two bonds. Some exist here and some exist here. But because alcohols, look, I want to show you something. How do we say, why do we say that? Alcohols will have the London force, will have the dipole force, and will have the hydrogen bond. So if this is alcohol, yes, these are non-polar things, atoms. Therefore, we're going to have London force here, London force. But here and here, we're going to have dipole. And then here and this, we're going to have hydrogen. That's why we say that all compounds which have hydrogen bonds, I'm not talking about non-organic like water. I'm talking about this organic. They have the London force, they have the dipole force, and they have the hydrogen bonds. Class, am I clear? Am I clear there? Let me know if I'm clear in that regard. So they have London force, dipole force, and then hydrogen bonds. So basically, when we compare it with the boiling point, those compounds which have hydrogen bonds, yes, will have a higher boiling point and a low vapor pressure. Therefore, they will require more heat to heat them so that they can boil. They will have those which have dipole versus the London force. The dipole will have a higher boiling point and a low vapor pressure. And then now, what if I'm just comparing compounds with only London forces? We shall see how many carbon atoms do they have. If they have long chains, therefore it means that the London forces are greater in one molecule over the other. Sometimes they even ask you, is the experiment fair? How do we answer this? It is only fair if you are comparing the same homologous series and then the number of chains, the number of carbon atoms are changing, and they are changing in a specific range. But if you have 2 carbon atoms and then the other one you have 3 carbon atoms, and then this is a haloalkane and this is alcohol, that's not fair because 2 factors are changing. So what caused the change? So there are so many questions we can answer here. I think I'm going to stop here for today. Don't forget to subscribe, you like, and also share to others. Tell others that we have started the helping part of physical science. We have not been giving it much time, but we see that students really need help with the physical science. So we're going to give you maximum attention on physical science so that we see that we help you out. Let me see if you have questions to ask. My number is always there, 0848-3317-38. You find me and then we can help you out. And also don't forget to join to subscribe for our booklets. Yes, you see there on the link, just it shows that get the books or get my books. They just click on that, and then many resources in that regard will help you 100%. M.Saidi, as usual, I wish you the best and good luck for those people who are writing tomorrow. Unfortunately, I would have helped you, but I can only organize the class tomorrow. If you write before we put the live, sorry for that. If you write after the live, definitely you will benefit. God bless you.